Hi, Vox Zurich. It's a pleasure to be here. And today we're going to talk about wiring cloud-native applications for local development, right? And I think most of us in the audience here are developers. And it's a little bit unfortunate fact that with how the recent developments in the infrastructure, in the industry have been going, unfortunately, because running our code, running our applications is so much more important because that's what actually brings business value. Whatever decisions are made very often, production always wins. If something is necessary in production, it's going to be done. There's going to be money for that. There are going to be budgets for that. They're going to be allocated time for this.
Yep.
And production needs always outweigh the needs of developers. And well, nothing is easy and glorious, right? Somebody has to take a little bit of effort to make that working. So developers usually, unfortunately, pay for all the advancements and all the good things that you can have in production, and you pay for it with your developer experience, with your local setup complexities, with how much you need to learn to stay up to date. And this is what we want to a little bit address during the session. And this is what we're going to talk about, how cloud-native applications that you want to run in certain ways in productions, which is very often deployment specific, right? There are clusters, there are deployments, there are things that you need to do for that, and how that doesn't fully map easily to the application developer worldview, where we work on applications, right? We normally don't work on deployments, right? So there is a mismatch of tooling, there is a mismatch of how the workflows and processes are organized, and we're going to look at this and we're going to try to see whether we can do better.
Yeah, that's the whole plan. And most of the time when we talk about cloud-native applications, we are talking a little bit more about like polyglot scenarios, right? Like where we have applications from different languages using different tools, coming with different practices into the play. So that translated to production means a lot of complexity, and pushing that to developers is not that, that good. So my name is Mauricio Salatino. I'm working for a small startup called Diagrid. I'm working on this open source project that's called Dapper, and also a CNCF project called Knative and Captain. I recently published this book last year titled Platform Engineering on Kubernetes, and I think that that's the main reason why I'm here speaking with Oleg, who is closer to developers. I'm a developer myself, but I've been working a lot with infrastructure for the last 6 or 7 years, and always pushing for tools that simplify the developer life when we're like dealing with all these complexities. So this book has a very, developer-focused approach to all the world of Kubernetes and all the tooling that it's been created there in the last, 5 or 6 years. That it's kind of like a lot of technology in there, but it actually makes developers' life more complicated. The book, I have like a discount code in there, and I have 1 copy here. If you come after the session and ask an interesting question, you can get a copy. But I'm also covering this book in the official CNCF Kubernetes book club. So if you want to join there, it's free. You can join and learn a little bit about, we are doing discussions every chapters. I'm here with my friend Oleg from Docker.
Yeah, if you won't be convinced after this session that you don't really have to learn Kubernetes, you can. There is a book for that.
Take
right?
a look.
Take a look at the book. Right. My name is Oleg, and I work at Docker. I work mostly on test containers and developer relations. Since Docker acquired the startup Atomic Jar, which I was a part of before, I don't have any books. Yet, maybe. It's a dream. But if you want, you can find me online, ask any questions, or you can subscribe to my YouTube channel, where I go to conferences as a DevRel person, and then I find people and ask them technical questions. So you can check it out. And if you don't think it's very lame, subscribe.
That's good.
You don't have to, right?
Do you want to introduce our context?
Right. So we wanted to show and look at how our application development works and how it specifically works for the sort of typical cloud-native projects, which are a bunch of different microservices working with different infrastructure pieces all together. And because we're so close, this is the closest I've been to Italy. So naturally, we had a pizza store application as our sample.
And we have Mario here in the audience, so like,
Yeah, who
it's
doesn't like
perfect.
who doesn't like a
like a
pizza?
good pizza.
Show us, show us.
So basically what I wanted to show you is this very, very simple application that we created just to demonstrate some of the concepts. You can run this application locally, of course, if you want to, and run all the services separately. It's in that GitHub repository, Šelajev/pizza. If you're interested in that, of course, there is some YAML and some Kubernetes configurations in there, but again, we are going to show some of the test containers magic as well. The application is pretty simple. Again, it's just for demonstration purposes, but we wanted to highlight a normal application that will have a bunch of services. They are communicating between each other using events, but also they are storing some data in a persistent storage like a database or like a key value store. So the application architecture is pretty simple, and let's see how the application works. Again, nothing surprising, but I think that applications that are storing information, retrieving information, and exchanging events are quite typical applications, right?
Yeah, there are 4 microservices there, and like you can expand that infrastructure of boxes to have whatever purpose you need because they communicate. You can cover all the use cases with that.
Yeah, that's the whole idea, right? So the idea of the application is that you can place an order, and what you will see here is like the different services picking up this order and just doing something with it, right? Like sorry, of course, that I will mess it up with the, let's go back.
You're good.
Yeah, I'm good. Let's place the order again. So basically what it's doing here is that we see the order on one side, and then we see the events that are being emitted by each of the services, right? So we have the pizza store, and of course it's mixing up the orders there, like that's the event for the different order, but you can see the kitchen picking up the order, and then the delivery service is going to deliver that when the pizza is ready to your door, basically, right? So you have a bunch of services, they are doing different things, they are processing and storing data in different data stores, and then they are exchanging messages to the pizza store so it can be sent back to the UI. The flow, it's pretty simple, and the whole point there is that, again, you can expand it and just implement different patterns inside this application. Again, simple scenario.
Yeah.
So you can just run multiple services, you will have different containers, and then if you try to run this in a cluster, in a real production environment, you will need to have and install different tools to actually make this application scalable.
Yeah. Like, of course, you need to learn some tools, you need to know how to run a Kubernetes cluster, and so on.
Yep. So if you think about this application, right, like it's not only about the services, it's about the infrastructure that this application needs in order to work. And we ask, what did we ask? Like we used DALI or something like that?
Yeah.
To create a diagram?
A diagram how an application like this could be imagined, and
Exactly.
it contains a bunch of services, and it's pretty close to the actual implementation. There is a whole bunch of things that you need to run in your cluster, and they all work together as if by magic.
Yeah, and as you can see, like it clearly identified that maybe you can use Kafka to exchange messages, and then it will become messy at some point the more services that you add, right? Things will get complicated, and managing all this infrastructure and the connection between the services, it's always tricky, right? So it's like a recurring issue that developers will need to face.
Can we sprinkle a little bit more cloud nativeness into this application?
We will do that, right? So, and in order to do that nowadays, we will show how this application is running on Kubernetes. How many people here is using Kubernetes? Can I see some hands? There you go. You see?
Everyone.
Lots of cloud native people here.
How
So
many like using Kubernetes?
Okay, we have.
Fair enough.
That's a very good number. It's more than one.
Very
so
good.
that's very good. I really enjoy using Kubernetes, but I totally understand that it's much more complicated than it should be. We are getting there. I think that as a community, we're getting there. We have more tools now. So I will just wanted to show pretty much kind of like how this application is running there. Again, you can find the instructions to run this on your clusters in any Kubernetes cluster by just running a bunch of commands. But I wanted to show here is that we are using PostgreSQL for storing data from the application. Every time that we get an order, we store that order into PostgreSQL. And of course, we use Kafka here to communicate the services using messaging, right? This by itself push to developers to make a lot of decisions. And if you're a Spring Boot developer or like a Java developer, a Quarkus developer, you will need to make some decisions when you start writing these applications. Some of those decisions is knowing about these two infrastructure decisions. Like I know that I will be connecting to a PostgreSQL database, and I know that I will be sending some Kafka messages. So I need to make sure that I will need to add, the right dependency system into my applications to be able to communicate. And this is, again, it's just showing the Kubernetes aspect of it, like just pods and deployments and some infrastructure running inside the cluster. But sometimes, most of the time, the infrastructure will not be running in that cluster. So you will need to know how to communicate with the infrastructure and how to get things working, right?
Yeah. And you're going to use, in production, you're going to use production-oriented tools to make that happen.
Yes.
Configuration, install things into your Kubernetes cluster.
You will probably need to install some observability tools like Nele presented before, and all the things that you will need to run this in production. For this case, we wanted to follow kind of like what Oleg was saying at the beginning of the presentation, right? That production wins. And this application here, we implemented it using a project that it's called Dapper, the project that I'm working on. And as you can see here, you will see that every application service had 2 containers running. One is the container from the application, from the Spring Boot application that it's running the logic. And the other container is from the Dapper project. How many here are familiar with the Dapper project? So how a couple of people. Yeah, it's not that popular, but it's becoming quite like an interesting thing. Again, it joined the CNCF a couple of years ago. It's a project it was created by Microsoft. That might be why it's not so popular in the Java space, but way much more popular in the .NET space. But it's been built for like polyglot, it's like a polyglot tool. You can use any language. And I wanted to explain a little bit about how that affects the application architecture and the benefits of using tools like this. So Dapr stands for the Distributed Application Runtime. It's a very maybe confusing name, I would say, from like what does it mean? It's very abstract. It's like a framework, but for cloud-native applications. So what it does, it expose some APIs for developers to use to basically implement business logic, like your application's logic, right? Without worrying about the infrastructure that it's going to be used to actually implement that logic. And what I'm saying here, like in a different way, is just abstracting away infrastructure and providing a bunch of like best practices and out-of-the-box patterns that you can use when you're building distributed systems. So what this image is basically showing is that your applications can, interact with infrastructure like databases, key value store, message brokers, secret stores, configuration stores, or whatever you might think that the applications will need from the context where they are running. In this case, using the Dapper APIs. So without going straight away to the infrastructure, they're just going to go through an API layer, and that API will communicate with the infrastructure that it's depending on the environment. Does that make sense?
Yeah.
So Dapper out of the box provide components, and those are the APIs that are exposed. And as you can see here, we have APIs and implementations for those APIs. So what you can see here is that we have state management for storing and retrieving state. And we have different implementations, not only for local things like running your own PostgreSQL or your own MySQL, but also cloud provider specific services like, Cosmos DB or like the AWS one or, like Google in-memory store or whatever you want to use. So you have the same APIs. You can change implementations that basically will allow you to move your application from different environments without actually changing the application code. You have the same for publishing and consuming events, and you have the same things for integrating with other systems. You have workflows, you have patterns around this that are becoming kind of like quite a thing. At the beginning, Dapper was just a bunch of simple APIs. Now we are building complex features on top of these APIs, right? Like we have orchestration, like workflows, coordinating, messages and how do you state store. And then you have patterns like distributed logs without pushing developers to think about the implementation on how this distributed log will work for a distributed application. What does it mean for our application?
Yeah, for our application, the infrastructure means a little bit like every service is augmented with a Dapper sidecar container.
That's correct.
And then it handles the communication above. What does it mean for us as on the deployment level? It means that we need to install Dapper into our Kubernetes cluster. And that means as a developer, if I want to work with a similar setup, that would be something that I need to be aware of and work with, because it's not just now purely a Kubernetes cluster. And however, my ops team and my production environment might love the setup because it's great. As a developer, this is something that I have to pay with
learning
and with the learning curve and with the onboarding experience and so on. So
what you gain from these kind of setups is that now Dapper automatically, when you install that in your cluster, will automatically recognize your applications and say, this application needs to interact with the Dapper APIs, and it will inject that sidecar that will now contain all the logic to communicate with the infrastructure. Again, you are making your applications completely abstract from the environment where they are running. So you can provide different configurations for different environments, and you can just keep your application logic separated from those APIs. This is something that we do kind of like in the Java space, right? Like we have our own abstractions to communicate with, SQL databases, like NoSQL databases with, with Kafka and different message brokers. This is taking it like, the next level on the cloud native space of removing the responsibility from the application container. Now Dapper is injecting the sidecar that will run very close to your application, and it will expose these APIs for the application to consume this functionality. So now the database drivers, the Kafka clients, and all those things will be not inside the application class path. They are just removed away from it. And that takes a lot of responsibility for the operations teams that needs to make sure that all the applications that are using Kafka are connecting in the same way, that they all have the same retry mechanisms, and that they all behave the same no matter in which language they are written. That's kind of like the main thing around Dapper. That's the main kind of like functionality that we're providing. Also, one more thing, it's because it's running very, very close to the application. The latency of connecting to the Dapper APIs is pretty small. And you can use something that we will show is like the Dapper SDKs for Java, but you can also send gRPC or HTTP request to interact with these APIs anyways. One more thing before we go from this slide is that the communication here is not unidirectional. So it's not like my application calling the Dapper APIs, but Dapper APIs can also call back onto the application, right? Imagine that you get like a message from Kafka. We want to make sure that whenever Dapper gets a message from the application, it can call back the application as well. So it's a bi-directional communication there.
Yeah, and it's great for production.
Yeah, that's the main idea. Remember, we have an API, so if you have an API, behind the API, you can implement best practices, and you have all these cross-cutting concerns like observability, security, resiliency, right? Now you can configure how do you retry connections to your databases in the Dapper side instead of in the application side. The application focus now on like the business logic. And of course, most of the Dapper usage is on Kubernetes, right? Like because it's a Kubernetes extension, so it makes a lot of sense that you do that, but you can also run it outside of Kubernetes as well if you want to do that. So
and you get of course like a various, as you mentioned, you get like resiliency and like security, observability, all the functionalities that you as a developer don't want to think about because they're not actually like business value, right? You get them out of the box. So the thing is, as a developer, right, even if we abstract away from using cloud native technologies like Dapper or something, right, how does our application look like with boxes where they're like on the code level, right? So there is probably the yellow boxes are the services that we can work on. Usually we would work on a single service at a time when we implement new functionality for that. So that is our area of interest. And there's a lot of things around it that we need to have and we need to understand, like as a developer, to work, to introduce changes to the applications, right? That includes understanding a little bit containers, includes understanding Kubernetes, includes understanding the infrastructure like our Kafka or Postgres or other technologies, the drivers, the connection details, and like honestly, for the application developer, what you really want to concentrate on is actually the yellow boxes, because those are the things that you're actually going to be changing. This is where your code sits, right? You are not developing like a Kafka driver. You are working on the application code, and it needs to connect to the like certain message queues and get things. So that is what I'm interested in as an application developer. And if I would work on these things only, that would make me very productive and very, very happy. Unfortunately, there are all those other things around it, which I need to learn and which I need to study and I need to understand.
One thing that I like to think when I see these kind of diagrams is that you need to think about how much do you need to teach someone coming out of university to work with these kind of applications, right? How can we reduce that time just to make it simple to say, like the pizza store is receiving orders. When you receive an order, make sure that you store the order somewhere and then that you emit a message. How difficult could it be to implement that on code? And how difficult are we making our own lives?
Yeah, exactly. So the complexity of the setup, right? We didn't do anything like groundbreaking. Right. We just have a pizza store application with a couple of microservices. We want to deploy it into Kubernetes, and we want to use like a popular and like sensible project that is targeting the operations concerns very nicely, like Dapper, and we want to work with this setup. Now, to work with that, as you said, you need to learn unfamiliar tools. You need to figure out like what is a Kubernetes, what is Helm, how to install things into Kubernetes, how to install different maybe infrastructure components into the same Kubernetes cluster, how to connect things together, how services will figure out and discover each other. It brings unfamiliar tools that you need to learn. It brings the Kubernetes complexity where you need to understand how, not just like know how to do basic things, but like you also need to understand what to do when stuff goes wrong, right? Because that's stuff always goes wrong, and you as a developer need to fix it both locally or in your CI environments, and all the way up to production, right? And that you need environmental parity, right? To be efficient as a developer, you need to be able to reproduce failures easily. You need to use a setup that resembles production, that uses technologies that you're going to use in production locally, because otherwise you're going to get stuck, right? And no amount of beautiful code without code smells will help you if you cannot run your application locally. Because
you need to have confidence, and I think that with Kubernetes we have learned how to run workloads in a very efficient way with the right interfaces, right? Like we know how to create containers and how to run containers, but how these containers communicate with each other and how they communicate with the infrastructure and available services, it's something that we are still working on, right? I think Dapper is one step into that direction, but there are tons of other things that we should be doing.
And the question becomes, like, how do we, like, it's not just we write code and then like throw it over the fence to ops team. How do we test all this infrastructure? How do we enable, like, how do we verify that what we do is actually sensible or not?
Yeah. And I think that that's kind of like the main question here, right? Like I was using Dapper a lot. I kind of liked it when I started working on the project. I thought, okay, this can help developers a lot. But at the same time, I thought, okay, but if you need a Kubernetes cluster, you need to install tools in that. Then you need to learn about these tools to understand that you are using them correctly. It gets complicated. So I started like looking for different approaches to run these tools for local development. And that's why I think that we came up here. And one main driving force is that we know that developers love APIs. So if we give developers APIs, we know that they will know how to use them, right? Like I think that that's a given. But if we push them to learn how to configure those APIs or the implementations of those APIs, then it gets much more tricky.
Yeah. As long as you can build tools for yourself and figure out workflows for yourself, we're good, right? That's what we're paid to do.
Exactly.
So how does Dapper API look in the code level?
Exactly. So let's take a quick look into how Dapper looks when we look into one of the services that it's doing stuff, right? Like I mentioned that the pizza store is basically storing data into a persistent storage. In this case, we are using PostgreSQL. But from the development point of view, let me show you here. There is just a very simple call here, save state here. There you can see it. Let me make it bigger if I can. I will mess it up this, right? Like it's a very, very simple API. So here I have the Dapper client, which is basically a way to connect to the Dapper APIs using an SDK that allows you to basically tell Dapper, I want to save some state and I have some orders in this case to store somewhere, right? Do I want to store it in PostgreSQL, in Redis? Do I want to store it in a managed service, in a cloud provider? From an application perspective, I know that I want to store some keys into a persistent storage, in this case in a key value store. And I just call that code and I don't need to do much more. In the same way, if I want to, for example, emit a message from any of my services, I can do something the same. With the Dapper client, I have a publish event thing. I have some parameters like where do I want to publish this event and in which topic, and then the event payload itself. So again, I don't need to know Kafka or how to encode my Kafka message here. I'm just going to send an event. And because again, I'm using the Dapper APIs, I can trust that these APIs will try to use sensible standards where they can, right? In this case, below the APIs, we are using cloud events, that it's a specification for sharing events across systems. So, you have like a shared API level where layer that can be standardized in some way. And I think that that's always good. Most of the time, like when I've seen like large implementations in the Java space as well, is like you as teams, right? Like you try to standardize these things for, like if you have multiple teams working on different applications, you come up with these kind of things, this kind of abstractions that say every time that we send a message somewhere, we have like a company specific API to do that. This is basically an open source project that it's trying to take the lessons learned from multiple companies and put it there for people to use and to use as a starting point for your own abstractions as well. So simple APIs, developers can work with that, right?
It looks like this. So how does it work in the local environment, right? So the question is, if I want to run this, right?
Yeah.
I need a Kubernetes cluster because this whole thing works in the Kubernetes cluster, right? I need to work with it, and I need to be able to do that. And as a developer, I don't want that, right? As a developer, I don't want to change my workflows. The same way I work on a small application locally with my local infrastructure, I want to do that with the more complex cloud native setups. So how do we solve this problem? Of course, we gonna use test containers for this setup. How many of you know test containers? Very, very good.
That's good.
Better than Kubernetes. How many of you like test containers?
Yeah.
Yes, thank you so much. Very good, very good. So for people who are not familiar, test containers are a collection of open source libraries that give you API to work with containers for pre-production use cases, right? So you can configure, you can manage the life cycle, you can configure applications within the container. You can get the connection details to connect to various pieces. And it gives you the whole ecosystem of pre-configured abstractions, the test containers modules, where you can use just a couple lines of code to spin up particular technologies. It works and it looks a little bit like this, right? So here's my ID. Here's my ID, and say I want to create something and use a service, right? I can add my test containers library into my POM.xml, and I can say, let me start Redis. And I just do new generic container, which is the low-level API. I provide the Docker image name, which would be the Redis, some version of Redis. I can do the whole configuration for test containers, right? I can expose the ports that I need, 6379, I think, for Redis. And I have the API to handle both the lifecycle of my containers. I have the whole API to work with containers. Like, for example, I can get logs for the container, or I can copy files from or to containers, and I can do anything that you want to do with containers, but I can do programmatically. And of course, if I would like to connect to this service, I can also say like Redis, and I can say plus Redis get host, right? And get the connection details where it's running. So get first map port, right? So a very simple example, I can run this. It will find a Docker environment in which it wants to run the particular containers. It will pull the containers automatically. It will handle the lifecycle as we ask it. It will give us the connection details as we want it here. So I can wire it programmatically, and it's really, really easy to use tool as a developer, because again, this is just APIs, right? You called it, you know how to do this. And on top of that, I can have the abstractions. There is, let me show you, testcontainers.com/modules, right? There is a whole ecosystem of technologies that would work out of the box for these. So for example, if I need my Kafka, I just need to say, oh, give me a new Kafka container. And I don't need to know how to run particular technologies in containers as an application developer, right? So I can say something like here, new Postgres container, and say...
I need to say the
what?
image, right?
Yeah, I need to say that this is Postgres, well, say 16 Alpine, right? I think 16 Alpine is the last one. And this would be my Postgres container. And I don't even need the configuration there, because the abstraction provides the sensible defaults for how I want to configure that, and gives me the configuration convenience API to work with those containers naturally, right? So I can do that, and then my but it's still called Redis get JBC URL, but it's Postgres, right? This is very good. What it shows us that as long as you have good tests, the code quality will take care of itself. Right, so very, very simple setup. It's integrated in your application frameworks. There is later a session about Spring Boot by Stefan.
Yep.
Right, they're gonna talk a little bit about test containers integration with Spring Boot as well. So it's a great tool. It's very versatile. You can hack together and bring tools instantly in it. So that means there's this situation where you know it, you love it, and when you have a tool, right? When you have a hammer, every program starts looking like a nail,
Definitely not that one, right?
Right, wrong nails, sorry.
Yeah.
Everything looks like nails.
There you go.
So now we have a problem that we need to bring the Kubernetes cluster, right, and this production environment into our development practices. Can we do this? Yes, of course. I just showed you how, right? We go to our modules, we ask our modules if we have Kubernetes, right? And we have a bunch of implementations. So for example, we have the K3s container where we can start Kubernetes without any worries, right? So if I go to my different service, right, I can do exactly that. I can have my Kubernetes set up where I import my K3s container and I can say that, ooh, please give me a Kubernetes cluster. And I can do even like cool things where put multiple containers on the same network to enable the configuration and communication between the tools. I configure that and it's all programmatic. So if I run this test now, it will run my Kubernetes cluster in my Docker container and it will expose me an actual Kubernetes cluster. So I can programmatically install tools into that if I would wish to do so. I can install my application in there if I would like to do that. And it's a very decent approach. But do I? If I would need to do this, I would be able to do this. That's the point that I'm trying to make. But do I really?
You stopped it or something.
Do I need to stop something?
No, that's fine. That's all right. Kubernetes is not starting.
No, wait.
That proves a point.
No, wait. There is no point. That's not the point that I was trying to make. Let's do it simpler. Let's run the Kubernetes container, right? Get the kube config that we didn't touch for a while.
Yes.
This is gonna work, right? It's gonna break on the breakpoint of unbelievably expert levels. Don't do that at home. But I can show you that the Kubernetes cluster is actually running there, right?
Yeah,
and I can do kube ctl get namespaces, right? You can see that we get a bunch of them.
It works. Yeah.
It works. So I have a Kubernetes cluster, and I could potentially install Dapper on any other tools in there. But this is not the best experience ever, right?
Yeah.
If this is only the APIs, right? We as developers can build abstractions that we can use for this. So naturally, if there is Dapper that offers API and you can run services, and there is test containers which offer you some API and you can run some services in containers, naturally you can build the combination of those.
Exactly.
Right? So let's take a look at that.
Let's take a look at that. So basically what Olex is saying is that, okay, you can create a full-blown cluster and install your applications in there. But again, how relevant is that for your application developers that they are running a cluster in their machines? That might not be the best scenario here. And what we try to do with the Dapr and Testcontainers integration, we have a Dapr module inside Testcontainers that basically it's tackling, the developer day-to-day experience with using these APIs locally for their daily tasks. So what we do, it's pretty simple, right? Like we have our application, and what we make sure to do is that we will just create a Dapr container every time that our application starts or every time that we are testing our application. So the Dapr APIs have an implementation to work with for local development. We don't need to deploy our application to Kubernetes to use the Dapr APIs. Test containers and the test container module is basically helping us with bootstrapping all the things that we need to use the Dapr APIs. It's pretty simple. You can configure it in different ways, but the base experience is that now in your Spring Boot application that I showed you before, you can just start writing tests that will use those APIs, right? And if we go here, I wanted to show you basically the Dapr container, which is the first thing that I wanted to show, which is here. So we have a Dapr container, which basically knows how to configure the Dapr container to run and expose these APIs. We have a couple of different profiles that basically define how many Dapr APIs do we want to expose depending on the complexity of your application and how much features do you want to use. But basically, you just have a container and we will start that container whenever the application needs those APIs.
Yeah. So instead of your application running in a cluster and Dapr running as a sidecar, your application runs locally as you want it to run because you want to change it, you want to debug it naturally, you don't want to package it, you want to run it as a local process.
Exactly.
And Dapr will run in the thing next to it.
Exactly. And of course, now that you can because you have like the Dapr APIs there available for your application, you can start writing tests for these containers application that is using the Dapper APIs. The only thing, we have different ways again of hooking Dapper into the application lifecycle, but we have this basically very simple annotation where you choose your Dapper profile, which will start different containers depending on what you're trying to do. But what we wanted to achieve with this is that besides adding a dependency to your application for test scope, plus adding this annotation to your test configuration, developers, the only thing that they need to learn is the Dapper APIs. They don't need to learn how to set it up. They don't need to learn about how it works. They just can go and use their APIs for their applications.
Yeah,
it's pretty simple, pretty straightforward.
Because somebody provided an implementation of that, right?
Exactly, yeah.
And in this case, this is your class that sits in your profile, in your application. It could be your developer experience team or platform team giving those abstractions to you, saying how to run particular things.
Yeah, I think that this is the basic building block to create deeper integrations, right? Like imagine that you're using Dapper and some other tools like feature flagging tools or something else, right? Like you can start building these libraries of different profiles of configurations, and you can share that across teams. So whenever they start their application, this thing will be started by test containers. And if you're using kind of like Spring Boot 3, you can also use this for running the application locally with this test configuration. That is something that I wanted to show here. That it's pretty, that I find pretty interesting. There you go, back. Which is basically the same. So I will go to the pizza store, the pizza store service, and I will do MVN with Maven, Spring Boot, test run. In this case, I'm not running the application, because if I run the application alone, like in the way that I will run my application in a container in production, the Dapper APIs will be provided in the Kubernetes, space, like by the sidecar. In this case, that I'm not running in Kubernetes, I want test containers, like the configuration that I have for my test, to kick in and run alongside my application.
Yeah.
So if you look here in the logs, you will see that test containers is starting that, and it's also starting wire mock to mock some of the other services of the application. And that basically allows me to go here. I will stop this and basically go again to the website, right? And I have my local, instance running here, and I can place an order. And of course, it will show here in the logs that it's actually storing that order into the database, and also calling the kitchen service that in this case is mocked, right? Like I'm not expecting the kitchen service to respond here or to send any event, but at least I can test the local functionality of this service on its own.
So for working on this application locally, right, you have the full environment to run this application, and all the sort of service dependencies that you need being managed and run by the test containers components inside your Docker environment. And you can do that. It's not just Spring application. I wanted to show this as well, because very quickly, right, you can build this into any sort of application that you have, right? In Java, there are a number of different frameworks that support this. And if you're working with different languages, because both Dapr and Testcontainers are available in other languages as well. So if you have other colleagues working in a different ecosystem, you can tell them to check it out, right? Node.js, for example, or .NET or Golang, right? It's all there. So I have here an example of a Quarkus application, which is the same pizza resource application, and there are some tests, and the tests are very, very similar. And because Quarkus has this batteries included concepts, where the framework thought through a lot of developer experience points for you, they have different services and different concepts integrated. So Quarkus, of course, has the dev services built-in feature where they would spin up the resources that you need with test containers. If you don't provide the configuration where to find that, that would work for databases and Kafka and everything, but it will also work for Dapper. So I can start my Quarkus application here, right? And under the hood, it will work. It can run my tests. It can. I don't understand why this is here. It wasn't here before.
There you go.
Right. So it can run my tests.
Dapper is starting there.
Dapper is starting, and then somewhere under the hood, it will run through the integration, and it will also run the Dapper container from the module that Mauricio contributed to the test containers module, with the configuration. You can override that if you wish to, but the batteries are provided. So as an application developer, I don't need to think about Kubernetes. I don't need to think about complexity of my service. I can just run my application and concentrate on the changes that I need to do. And I can verify them because I can run my tests locally. And they will run with the technologies that I use in production. But it's going to be a very application-centric setup where my user experience is the same as everything.
Yep. And again, remember that we are showing here for like the Dapper integration because I'm working on Dapper and he works on test containers, but this actually applied to a bunch of different projects that you can use, right? Like even for like your internal services that you can mock or run.
You can do containers like that and configuration like that for your internal services, for your internal mocks, or your particular versions of cloud native technologies. Or you can even work with public clouds and infrastructure like that.
There you go. And that takes me to the next point, right? Like why stopping at the local development experience? And this is something that I've been working very close with the team at Diagrid. We are building kind of like a cloud offering. And because we work kind of like with these generic APIs from the Dapper project, we wanted to take all these APIs and just push them outside of Kubernetes clusters, right? So what we are doing is basically taking the APIs that you can run now locally with test containers or in a Kubernetes cluster into the cloud as a managed service so your applications can communicate. That basically also allows us to say it doesn't really matter where your applications are running. You can always contact these APIs that will abstract your infrastructure in any cloud that you want to do. And you can do even cross-cloud stuff. That's what we are building. It's called Diagrid Catalyst. We are like in early stages, so we are looking for developers to try this out. If you want to hack some stuff around these APIs, it's a very good time to sign up and help us and provide feedback. But the main idea here is that we can show a local development experience, we can show a Kubernetes development experience, but also like a generic, mostly like container application outside any cloud or any on-prem setup communicating with these APIs. And that is not always that good because it brings new complexities into the mix, right? Like when you start working with cloud services, and again, I'm telling the story around Dapper and the things that we are building, but it applies to a lot of the other things as well. When you start working with cloud and public services, the problem is that your applications maybe have an easy time to call these services because you're doing an API request, but then how do you make your applications available for this service to call you back, right? Like in this case of the pizza store, we were getting some events being sent by other services. So how can we get those events back into our application?
It's easy in production because you expose like your application publicly, right? And it's right there, and the clouds can call clouds, but it's not that easy in development. Exactly. And that brings us to like
the last part.
Look. More nails, right?
More
like we know the tools. We have the tools to solve these problems, right?
Yep.
So let me quickly show you.
Yep.
You can. This is the state-of-the-art, bleeding-edge development that is available as a GIST to the best of our abilities, right? So we're gonna use the test containers and we're gonna use the ngrok tunnel for this. So look at this. I will create the ngrok container. I will provide a default configuration for that, which is the normal configuration for your ngrok service. It's gonna run the stock ngrok image that I want to. It's gonna start the ngrok and the tunnel, and when the container is started, it's gonna spit out the URL at me. So I'm gonna say, and I'm gonna run this. Oh, look, ngrok container. I'm gonna run it. I'm gonna expose that port on my local machine. So it runs. This is a little bit where the current integration is manual, but you can imagine how this can be fully automated, and this URL can be fed back into your application. Wait, what was the
user admin or something like that?
No, it's admin, and then I like trains. And you can see the publicly available pizza store application that is running locally. This is my Quarkus thing, right? This is my Quarkus application running here.
There you go.
I can wire any amount of cloud tools. I can wire any tools into my application workflows if I want with test containers, because it runs Docker containers. Everything available under sun runs in containers nowadays. So you can build whatever complex setups you want. You can wire it programmatically. It's not gonna ever kind of rot because the configuration is right there in your code. It will never change. Everyone in your team will run the same setup. Your CI will run the same setup if needed. And we just showed you how to do this with databases or or Redis, or Dapr containers, or ngrok services. So the sky is the limit. Your imagination, what will take you everywhere.
Slides and
So
finish.
let's finish this, right? We can build really, truly local and cloud experiences by leveraging the consistent API. So as long as the projects offer you the API, you can build the abstractions. And there are a lot of tools in the Java ecosystem that help you as building blocks to wire things together. And remember that while in production, you want to deal with production level concerns and configurations.
And you want to have the right tools there, right?
Yeah, and you want to have the right tools there. You can also use the right tools and a very streamlined developer-oriented approach in development where you want to work on your applications.
And I hope that we have showed some tools to make the developers' life easier, while at the same time having more complex environments for production where different teams will and can configure different aspects of infrastructure that they will probably need. We have shown like this consistent experience across environments, and I think that we will continue working on these kind of like integrations with ngrok and with different cloud services to show that the same experience of creating an application locally and having everything that you need to build that application and to run it locally and to test it and to debug it is pretty much the same as you move towards different environments. Yeah,
and that's it.
We have some resources.
There are some links that you can visit. If you have any questions, come talk to us or find us online. And thank you so much for coming. I hope it was good.
Thank you.
There's a feedback form that if you like the session, you should fill. And if you didn't like the session in particular, we are all ears in person. Thank you so much. That's a joke. You can give us all feedback. Any feedback is valuable.
Good stuff. Thank you, folks.